is on the volume of spheres, cones, and pyramids. This is the last lesson in this unit. So after this, you're going to have a hand-in assignment and a quiz or an exam to be doing for me. So probably just going to be a quiz because we did a quiz on surface area. So we'll just do a little quiz on volume to make sure we kind of get the understanding of both of them. So volume, measure of space a three-dimensional object occupies. You should remember that from last unit. Volume of a sphere is going to be 4 pi r cubed over 3. So we're taking that 4 pi r squared that we had for our area. We're now going to cube it instead of squaring r, and we're going to divide by 3. You're going to notice that dividing by 3 becomes a super common theme when we're dealing with volume of spheres, cones, and pyramids. So don't get too angry about it. So first things first, we're going to find out what the volume of this sphere is, and then we're going to take that volume and we're going to find what the capacity of it is. So first things first, volume is going to be equal to 4 pi r cubed divided by 3, where r is equal to 4. So I have volume is equal to 4 pi r cubed all over 3. So 4 times pi times 4 cubed divided by 3. So 4 times pi times 4 cubed is going to give me 804.25. I'm then going to take that and divide it by 3. When I divide it by 3, I get 268.1 meters cubed. Now, I know when we were dealing with capacity in the last lesson, I should say, we dealt with it with our centimeters cubed. This one I have meters cubed. So you can take it, you can turn your meters into centimeters, or you can use the following conversion rate. I'm going to give you one more conversion rate, and the conversion rate I'm going to give you is for meters cubed to liters. So we're going to figure out what that would be. So what that's going to look like is we have 1,000 centimeters per liter, which means that 1 meter cubed is equal to 1,000 liters. So this here also can be used, super important. Now when we're doing it this way and you're going from meters to liters, you're going to divide. Whereas when we were going from meters to liters, we are going to multiply by 1,000. Centimeters to liters, you're going to divide by 1,000. Super important. Don't forget that meters you multiply, centimeters you divide. So let's find out what the capacity of this one is. And the capacity of this one's going to give me the following. I'm going to take it. I'm going to take my 268.1. And I'm now going to multiply it by 1,000. So when I multiply that by 1,000, I get 268,100 liters. No different than cross-multiplying if you chose to, but if you remember, meters you multiply, centimeters you divide, you shouldn't have to cross-multiply. So this is what C is going to equal. C stands for capacity. So if you ever see me write C equals, it's probably capacity is equal to this. So these are your two answers. This is your volume. This is your capacity. We are now going to take a look at the volume and capacity of a pyramid. So a pyramid right here has what's the volume and the capacity of this pyramid. So for a pyramid, our volume is going to be equal to 1/3 the area of the base times the height of the pyramid. So in this case, we don't need to find our slant area. We don't care about our slant area. Even better. Makes life really easy. If you're given slant and you don't know height, then you're kind of in a tricky spot because you then have to use your Pythagorean theorem to find your height. But in this case, we don't need to do that. So our volume is going to be equal to 1/3 my area of my base, which was length times width. And then I'm going to multiply that by my height. So I can now take my length is equal to 18, my width is equal to 15, and my height is equal to 25. I can plug those in. So I have 18 times 15 times 25, all divided by 3. And when I type this into my calculator, I get 2,250 centimeters cubed. Now, I want to know what my capacity is. So this is my volume. I can use that number to figure out what my capacity is. So remember, in capacity, if we have centimeters, we are dividing by 1,000. If we had meters, we were multiplying. I have centimeters cubed, so I'm going to take 2,250 divided by 1,000, and I'm going to get 2.25 liters. Remember, capacity always measured in liters. Last example here is finding the volume and capacity of a cone. So the volume of a cone is the volume 1/3 the area of the base times the height of your cone. Once again, we don't need slant height. So in this case, that means that we're going to have a volume of pi r squared, which is your circle, times your height, all divided by 3. So I have a radius of 3, a height of 4. So I can take those, plug them into this lovely formula that I've been given, and go from there. So volume is now going to be equal to pi times 3 squared times 4 divided by 3. And when I type all of this into my calculator, I get 37.6991 centimeters cubed. You can round it to 38 centimeters cubed if you choose to. That's fine. Now that I have that, my capacity, once again, we're in centimeters cubed, so my capacity is going to be dividing by 1,000. So I have 38. My bad. Here we go. Let's get rid of whatever this is here. For some reason, I've got a weird shape showing up. Let's delete that. There we go. So now we're going to go back and we're going to have 38 centimeters cubed divided by 1,000, and I'm going to get 0.038 liters. Remember, capacity is in liters, volume is in cubic units. This is the end of this unit, the end of this lesson. Don't forget, use your units, cubed, squared, depending what you're doing. If you have any questions, please ask. Your next assignment is going to be out tomorrow, so you'll have a hand-in assignment, and then you will have a quiz on volume. Your quiz will be strictly on volume and capacity because we had a quiz on surface